Hoy vamos a hablar con Tim Allclair. Es un ingeniero que trabaja en nada más y nada menos que en Google y es un experto en seguridad de Kubernetes, de contenedores. Está en el comité de la comunidad de seguridad de Kubernetes, o sea que es un tipo que no solamente sabe mucho, sino que también provee mucho y comparte mucho de sus conocimientos. Así que para mí es un honor estar charlando con una persona que sepa tanto de algo que yo no sé mucho, que es seguridad en contenedores y seguridad en Kubernetes. Así que sin ir más lejos, les voy a dejar la entrevista. Recuerden que están los subtítulos en español para aquellas personas que no saben inglés. Solamente tienen que tocar la tecla C, creo, en el teclado, o hacer clic acá o acá, ahí arriba, depende del teléfono. Los voy a poner ahí para que ustedes puedan seleccionarlos y ver el podcast que está en inglés nuevamente, porque la persona habla en inglés, pero van a estar con subtítulos en español. Así que bueno. Okay, thank you, Tim, for being here. Can you tell me a little bit about yourself? What do you do at Google, and what do you do outside of Google as well?
Yeah, thanks for having me. So I work on Kubernetes at Google, specifically Google Kubernetes Engine, or GKE. I joined that project in 2015, and I've been involved in Kubernetes ever since. I do a lot of work on security for Kubernetes, specifically around, in the past, I've done a lot on node security and container hardening and container runtime security.
Uh-huh.
I'm a member of the Kubernetes Security Response Committee that triages vulnerabilities for the open source project and leads incident response around those.
Uh-huh.
I've also been involved in SIGNode and I used to chair SIGAuth, but no longer.
Okay, you can tell me a little bit about that later. But one thing that is confusing to me is that most people think that containers are secure, right? Because they are like I know that this is a wrong definition, but it's like a virtual machine running, so it should be everything contained, and anything that is inside the container shouldn't be able to do anything outside the container. How real is that? Are they more secure than a typical instance or a virtual machine or something, or are they like the same?
You'll probably hear me say this a lot, but it all depends on your threat model.
Okay.
A big advantage that containers have over virtual machines is they're typically running a lot less within the container. So on a virtual machine, you often have your big application and all the logging and monitoring. It's all bundled together in one machine. So there's a lot going on in there. Between two virtual machines, you have a pretty secure boundary, potentially, if they're configured correctly. But you have a lot more attack surface within that VM. Now, with containers, you typically separate out a lot of that functionality. So often you have just a single process running within a container, which reduces the attack surface quite a bit. However, they are sharing a single kernel, and so you do get a slightly weakened security boundary there.
Yeah, the other day I made a video about something I realized recently, which is the user ID is tied to the kernel. So, for example, if I run a process inside the container under the root account, that's basically using the root account of the kernel, right? The host. Obviously, I know that you can do some configurations on the container to prevent that, but by default, it's like that. I was able to, for example, to mount a file from the host that the user that was running the container didn't have permissions, but because the container was running as root, it was able to get that file and read it and modify it and everything. So is that an actual problem? People are getting hacked, or is that a common vulnerability that we see on containers?
It is a somewhat common misconfiguration to mount too much of what we call the host file system. So you've got your container file system that's bundled up in your container image, maybe a few volumes, but you can also mount files or volumes from the host that it's running on, and get access to those where you shouldn't. Now, what we call containers and think of as containers is really just a collection of different Linux features for limiting processes and namespacing them. So you've got namespaces and C groups and things that kind of uh, isolate and contain the process. And then you've got a bunch of other security features like seccomp, AppArmor, SE Linux that are further reducing that attack surface.
Yeah, I know that you can run those containers rootless, right?
Mhm.
So configuring I know that now Docker is being deprecated, so they're using just container D, but still by default, is there a default configuration in container D that removes that problem with the root user ID, or is by default the same?
So rootless containers are sort of a confusing
Okay.
term. So it's definitely a recommended best practice to run containers as a non-root user. Similar to how if you're running a process on a VM, it's usually best to not be running as root unless you really need it.
Mm-hmm.
And so the same applies to containers.
Mm.
Unfortunately, it's pretty widespread practice to run them as root anyway.
Yep.
Now, rootless containers is often actually referring to a rootless container runtime. So it's
Mm.
not necessarily talking about running the container as root, but running container D or even the Docker daemon
Yeah.
as non-root.
And and if you configure that, for example, container D or Docker daemon, I know that if you configure them as non-root, there are some limitations, right? You still cannot, for example, use some certain ports, for example.
Mhm.
Is that true, or is that expected, or do we need to configure it better in order to use those ports, for example?
So on that specific example, there's a syscall that I don't remember off the top of my head that enables an unprivileged user to
Okay.
bind to low-level ports.
Mm-hmm.
And actually, just recently, I think in Kubernetes 122, if I remember correctly, that's now enabled by default.
Oh, okay.
So unprivileged users can now bind to those privileged ports without needing to run as root or the netbind service capability.
Okay. Cool. I get it. So what you do is basically also like being part of that security community, and making sure that everyone follows the good practices. But what are the most common attacks? I mean, how can you, maybe we shouldn't put it this way, but how can you hack a container or a Kubernetes cluster? What are the most common things that you see?
Yeah, so by far the most common attacks come from misconfigurations.
Okay.
Typically, this looks like accidentally exposing a privileged service to the internet without authentication. Um, we've seen uh, we've seen some kind of some public attacks that have been documented
Hmm.
around, for instance, exposing an early version of the Kubernetes dashboard,
Okay.
which gave you full access to the cluster.
Hmm.
That was running unauthenticated and accidentally exposed on the public internet. We've seen
Got it.
similar things with nodes being exposed publicly. And then, kind of more on the container side, you have we talked about mounting host files
Yep.
that the user or that the container shouldn't have access to. Generally, kind of giving workloads more privileges than they need.
Hmm.
Um, the other most common type of attack and vulnerability is just around known um, known vulnerabilities that haven't been patched. So running unpatched services.
Got it. Okay, so basically it's just misconfigurations or exposing the wrong application that also has a vulnerability because they are an old version, maybe. But as long as you take those considerations, you should be fine. I mean, I keep thinking of an example of, let's say that we are running like a Go application inside a container, and that application is running as root. For some reason, there is a vulnerability that allows people to run commands inside the container.
Mm-hmm.
Usually, that doesn't mean that they can take over the host, because unless the container was configured not the right way, like mounting a volume or something, even if they gain access to the container, that doesn't mean that they can access other things, right?
Right.
Got it.
Yeah, as long as the container is configured correctly, and using least privileges, if it's running with best practices, that eliminates a huge number of vulnerabilities. If we look at a history of recent container escape vulnerabilities,
Mhm.
I think all of those are prevented by following best practices. So even before it was known, things like seccomp or SE Linux actually prevented those
Right.
escapes.
So there was a way basically to get out of the container before, right? I mean, some ways,
Mm-hmm.
and that should be stopped by SE Linux, as you said, or AppArmor, whatever.
Mm-hmm.
Okay, so those are the recommended tool to detect those vulnerabilities. Do you have any like a list for people to say, hey, go and check this list of things of good practices? Is there something out there that we can follow?
Yeah, there's something called the CIS benchmarks,
Okay.
which is a official list of security best practices.
Okay.
And those are graded. So not every one of those is going to apply to all
Yeah.
situations. It's not just a checklist that you can kind of blindly follow, but it's a good set of recommended best practices. And there's
Okay.
one that's specific to Docker or Containerd, and then there's also a set for Kubernetes as well.
Okay. So basically, the guidelines or the things that if I create a new cluster, I should go and check that document and maybe make sure that we are following the good practices. That will be your recommended way to start up to create a new cluster and follow the good practices.
Yeah, it depends on the environment you're running in. Just to plug one of our own products, GKE Autopilot
Yep.
is a GKE tool that is more opinionated than our standard cluster, and it enforces that you're following all of those best practices by default.
Mm-hmm.
There's
Yeah. Yeah.
a
Go.
challenge in the Kubernetes community that Kubernetes is very strict about backwards compatibility guarantees.
Mm.
So we really want to make sure that when you upgrade, you have a guarantee that a feature that you're using is not broken. Now,
Yep.
we sometimes break this through deprecations or mistakes, but with deprecations, we try to very gradually uh, roll it out with giving users a lot of advance notice. But the
Yeah.
problem with that, sorry, the problem with that is security changes often are sort of breaking a functionality intentionally. Like you're
Right.
saying, okay, an attacker used to be able to do this, and we want to no longer let them do that. And so it actually is very hard to roll out some of these security changes by default in Kubernetes. So that's why there's all these long lists of best practices.
Yeah, I mean, as an SRE, it's a pain in the neck to go and configure those securely because obviously, if you are being more secure, probably there are more effort in that configuration, and also you're going to see problems that you have to manage. Like, for example, I don't know, like a log agent or something. Sometimes they need to run as root and configure
Mhm.
it their way is tricky, right? It takes a lot of time. And so okay, so that will be my checklist or things that I had to do when I create a new cluster. But can you hack a cluster? I mean, uh, I'm sure that you will say something like, okay, yeah, before maybe not now because we should be fine. There is no CVE at this moment. But what are the most common attacks to a cluster? Basically, just using something like the Kubernetes dashboard as a vulnerability, or
Mhm.
have you seen attacks to the API, for example, or a scheduler making it public, obviously, and something like that, or no?
Yeah, so it's similar to what we talked about earlier. It's
Yeah.
misconfigurations and deploying old versions with known vulnerabilities.
Okay.
Um, I think the class of attacks that's known as 0 days, where
Yep.
you're exploiting something that's not already publicly known, is extremely rare.
Okay.
And yeah.
Cool. Knocking on good that's the case for from now on. What are the most common mistakes? I mean, you said using an old version, maybe running an application that is vulnerable. Are those the things that you see more often?
Yeah, definitely. Yeah, running unpatched versions of Kubernetes, running unpatched versions. I'd actually say that running unpatched versions of applications on the cluster is
Uh-huh.
probably the most common mistake that I've seen.
Uh-huh.
We talked already about some of the challenges of rolling out these security features by default. And so I see users just kind of expecting Kubernetes to be secure out of the
Yeah.
box. And unfortunately, there actually is a lot of work that needs to go in to secure it.
And why do you think? Because you keep saying that if it is configured properly and all of that, and you just mentioned that by default it's not that secure. Why? Why is that the case?
Yeah, so uh, it has to do with kind of the history of how Kubernetes was built. Unfortunately, the very early versions of Kubernetes were not built with security
Hmm.
in mind.
Got it.
And so a lot of the security features have been layered on after the fact. And actually, now Kubernetes does have a very active security community that's working hard to kind of push the bar, and we haven't seen any really critical CVEs in a long time as a result of a lot of those efforts. But because this was all added after the fact, and because of that backwards compatibility guarantee, it makes it very hard for those things to be enabled by default
Hmm.
in raw vanilla Kubernetes.
Right.
Now, there's a lot of tools for deploying and running a cluster, like GKE Autopilot or kubeadm actually has a
Yep.
more opinionated set of defaults than uh, just the kind of out of the box API server flags, for example,
Got
that
it.
do enable more of those.
Okay. Cool. So switching the topic a little bit, and probably most people are excited about service mesh, right? Service mesh
Mhm.
is like it changes everything. To me, it's much better because you give more visibility to developers. They are able to see their metrics, and they don't need to be adding the logic to the application, right? But
Mhm.
there is another word that is floating around there, which is eBPF, and I remember reading about it like a year or two ago, and say, okay, this is going to kill service mesh, but I don't think that has happened, right? Is this like a young tool? Maybe you can explain it a little bit before
Mhm.
we go deep. What is eBPF?
Yeah, so comparing eBPF to service mesh is a little like comparing containers to Kubernetes.
Okay.
So what eBPF is a powerful kernel extension mechanism. So before eBPF, if you wanted to say um, intercept and modify a syscall that a process was making to the Linux kernel,
Hmm.
there's kind of two ways you could do this. One would be to have a user space proxy. So
Mhm.
you have your process is actually wrapped essentially by another process or a library or something that's going to intercept those syscalls before they even get to the Linux kernel and
Mhm.
either modify or log or monitor or whatever you want with them, filter. The other option was to build a kernel module, which
Mhm.
is basically a way of modifying the kernel code. And unfortunately, a lot of the interfaces that you would take advantage of with the kernel module aren't really stable
I see.
interfaces. And so there's a lot of kind of developer pain. It also requires building a kernel and typically rebooting the machine. So it's very disruptive to
Mm.
load a new kernel module in and very highly privileged. What eBPF does is it gives you a just in time compiled uh, language essentially that you can load into the kernel and run in a sandboxed way. And there's all different hooks and places that you can run eBPF in the kernel. So one is for kind of intercepting syscalls. There's also hooks in the networking stack, which is, I think, what's more relevant here,
Yeah.
talking about service mesh, where you can do kind of lower level filtering or processing or monitoring on network packets within the kernel.
Okay, so I didn't know that it was that big, right? I thought I was only thinking about the networking part, but seems like there is a lot more than that. Are you seeing people using eBPF at the moment, or is this still young or early stages?
Yeah, people are definitely using it, especially around the networking piece. I think that's
Okay.
the more mature side of
Hmm.
things. There's some exciting developments around Linux security modules. So this is like AppArmor and SE Linux are
Yeah.
both security modules. But I can't remember the name of the project off the top of my head, but there's a project to use eBPF basically to load custom policy
Uh-huh.
as a security module there.
And again, with service mesh, I mean, it changes everything. More people, developers, they don't need to be caring about adding metrics or things like that to their application. But you are basically injecting a sidecar in all the containers and all the
Mhm,
pods.
mhm,
So obviously that is expensive, right? Because you are
mhm.
adding a lot of work. So do you think that eBPF is the better service mesh, or people should be using? I know I'm talking about only the networking part, or do you think that there is still place for both of them, and both of them are going to keep being used?
Yeah, I think we'll probably see a sort of hybrid approach,
Okay,
and we're already seeing this of eBPF being leveraged in the service mesh
got it.
environments, but you don't want to be doing all of your heavyweight logic in the kernel. That's expensive, and also eBPF has a bounded runtime
Mm,
intentionally, so it's not. I believe it's not actually a Turing complete language.
uh-huh.
Um, so you're still going to want those user space components to kind of augment eBPF. And now, whether those user space components look like a sidecar on every container or a daemon on every host, I think is going to depend on the specific implementation. But I do think that we'll see lighter weight service meshes as a result.
Got it. Yeah, yeah. I tried using Istio, and it went too big, and
Mhm,
people, I think they don't like that. I mean,
mhm,
it's trying to do a lot of things like those ingresses and gateways and all of that. And I personally like Linkerd. I don't know if there is a like a default service mesh in GKE. No, for now.
No.
Okay, cool. So you have to implement it yourself, basically.
Yeah, we have tools to support Istio.
Mhm.
I don't actually know if we offer Linkerd
Linkerd. Okay,
configuration out of the box.
got it. So changing this again, changing the subject a little bit, and now we should be. I want to talk about secrets, which is like
Mhm,
credentials for containers. Let's say the MySQL password, and I feel like there is no standard for that, right?
mhm,
A lot of people are implementing their own solutions. There is no. I mean, there is a standard which is the Kubernetes secrets, but I don't think they are too secure or secure enough. So, what do you think? I mean, what is the best way, or at least the way that you think is the best one to manage those secrets? Because people say, okay, yeah, just use Vault or something.
mhm,
Okay, but that's not solving the problem. I mean, there are a lot of things in the middle. Vault is just the back end, right?
mhm,
Um, are there any considerations or any recommended tools of or best practices about doing secrets in Kubernetes?
mhm. Yeah, so Vault is definitely the kind of the solution that I hear talked about the
Yeah.
most. Um, and there's a few different ways to integrate that into Kubernetes.
Okay.
Um, I don't think that the solution is to say never use Kubernetes secrets. They do
Okay.
have a time and a place, but it's a more basic solution.
Okay.
So places that Kubernetes secrets are useful for are kind of bootstrapping. So how do you get the credentials in the first place that you need to talk to that remote system?
Hmm.
They're also useful for things that are very specific to a single cluster context. So,
Got
as
it.
an example, a self signed certificate key pair for
Yep.
serving an admission webhook within the cluster. That's something that is very scoped to a specific cluster and doesn't necessarily need to have that remote system. Where the remote system is really useful is if you need to share secrets across multiple clusters,
Yep.
if you need to have users managing them and accessing them, they give you more fine grained authorization and auditing controls. and better tools for rotating and revoking secrets.
Right. But again, that's the backend part. And
Right.
I mean, I think, people are doing it in so many different ways. Are There are people like starting the application and on runtime getting the secrets from somewhere like a vault
Mm-hmm.
or a or a place where the secrets are. But that's basically you are adding more logic to the application that maybe they
Mm-hmm.
shouldn't be caring about, and maybe we should just mount them as environment variables, for example. But
Mm-hmm.
at the same time, where are those environment variables defined? I
Mm-hmm.
mean, I don't know. I mean, when people ask me, I say something like maybe you should use like an init container that gets the
Mm-hmm.
secrets from a backend and just mount them as a file into the
Mm-hmm.
final container.
Mm-hmm.
Do you think that's a good approach, or is there something better than that?
Yeah, so you mentioned the three different approaches that I see
Okay.
used most commonly is manually fetching the secret and kind of um, using the API for
Mhm.
that. That's the best approach because your secret is never it's never put on the file system. It's not in an environment variable. It's a lot harder for the secret to be leaked accidentally, or if you have something like an arbitrary file read vulnerability, it's harder to accidentally get the secret out that way. But it also has that cost that you mentioned of being adding complexity to your application.
Right.
Um,
So do you think that that's the best way because the secret is like inside of the memory of the application and it's not added as an environment variable or a file? Do you think that's
yeah,
the more
exactly.
secure, basically?
Yeah, I think that's the more secure. I don't think it's always practical. For instance,
Yep.
if you're using a third party application that expects to read its secret from a file, then you're going to have to provide that via a file. I think file based secrets are the second best option.
Okay.
You can use something like the secret store CSI driver to automatically mount the secrets as a volume
Hmm.
from various different secrets backends. Um, that's a pretty good solution for. I think it strikes a pretty good balance between security and ease of use.
So you said
The
secret stories. That's something from Kubernetes that I wasn't aware about.
Yeah, uh, there's a sub project of SigAuth,
Okay.
which provides this CSI driver. That's the
Okay.
container storage interface. It's basically a plugin volume driver
Got it.
for
Yep.
Kubernetes.
Okay. So basically, you are mounting the secret like on the deployment and the deployment manifest. You're using a driver to mount the secret directly from the backend, right?
Yeah, exactly. And so the interface there actually ends up looking a lot like using built-in Kubernetes
Yep.
secrets, where you're just specifying in your deployment manifest, like, give me this secret as a volume, mount it here.
Right. So instead of mounting the secret from the secret or in Kubernetes, you are mounting it from someone else, like a
Yeah,
vault
exactly.
interface. Got it. Oh, I didn't know that. Cool. I learned something. Uh, so okay, cool. So those are the best things that you think on how to mount in those secrets. One other thing that people are struggling, or at least I'm struggling right now, because we have not that many clusters, maybe for a company like Google, but for me or a 5 people team, 10 or 15 clusters is a lot, right?
Mm-hmm.
So, and right now we are using SSO, an integration. We're using AWS, by the way. So we're using an integration from AWS that mounts a service account, and you can link that account, service account, to a user, a YAML role,
Mm-hmm.
right?
Mm-hmm.
Um, but obviously, managing those users is a pain, right? Someone joins the company, you have to go and I don't know, run Terraform or something.
Mm-hmm.
Um, it's still a pain, but that's the best way, I think. Do you think there is a better way to manage those users? When I say users, I'm talking about humans. Humans
Mm-hmm.
that
Okay.
want to connect to the Kubernetes API. What is the
Mm-hmm.
best way or the recommended way to manage those users? Keeping in mind that maybe you have 15 clusters or more.
Yeah. Yeah. So I definitely think using a some sort of external identity
Okay.
provider is the
Okay.
way to go. So I can't speak to AWS specific solutions, but OIDC is the kind of the open standard that a lot of different identity systems implement, and Kubernetes has built-in support for connecting to an OIDC provider. And so that way you can configure all of your different clusters to use the same identity provider. And then you end up only needing to manage your identity in a single place.
Got it.
And you have consistent identity across those clusters.
Cool. All right. So let me check my notes. A lot of people are using more than one cluster to run their applications, obviously, and not only because they are getting too big, the clusters are getting too big. Maybe they want to like separate parts of the application. But how do you manage so many clusters? I mean, let's put an example of a small company with 10 clusters. In our case, we use Terraform basically to create those clusters. Do you think there is I know that GKE had like a way to manage several clusters. Is that the case? I don't remember.
Yeah, so Anthos has Anthos is part of our larger enterprise suite of software, and that has something called Connect, and a feature called Fleets, which you can use to manage multiple clusters. But GKE, Google specifics aside, I think the most important thing to keep in mind when managing multiple clusters is to try and standardize as much as that configuration across clusters. And so one of the big wins that we had with moving to containers from VMs was this idea that containers are ephemeral, and you can kind of create and delete them more rapidly and move them across machines, and the identity isn't tied to a specific instance that needs to be babied all the time. And so before, people were kind of more manually managing specific VM instances, and it was harder to recreate those or move them. And so I think we're kind of starting to hit a point where we need to start thinking about similar things with clusters. And I don't think that we're about to have ephemeral clusters that are being created and deleted all the time, but to have a more standardized idea of how what these different clusters are, so that if we do need to add one or maybe turn one down, it's much easier to do so, and there's less specifics tied to a specific cluster. For instance, if an application needs to scale up and move across clusters, it's easier to do so.
Got it. Okay. Yeah, that makes total sense. And again, changing the subject a little bit, there is a really important thing that is happening, I think, in the next version of Kubernetes, which is 1.24, I think, which is they're going to remove Docker. Oh no. What is that? I mean, people, I know what is that, but maybe you can explain it a little bit better. But when people say, okay, Docker is no longer supported in Kubernetes, people were freaking out, right? Because they didn't understand what that means. Can you explain a little bit what is that going on there?
Yeah, so I can explain that, but if you want a more detailed explanation, in about a month, on March 31st, there's an event for a free event for learning a lot more about this. The Docker shim deprecation. I think it's called After the Storm, Docker shim deprecation demystified.
So we are in the storm right now, basically. That's what you're saying.
Yeah, I don't know about that, but that's a panel of a bunch of really cool people from the broader Kubernetes and container community, who I've had the pleasure of working with. So highly recommend that.
Okay, I'll definitely put it on the description. You said that it's free, right?
Yeah.
Cool.
Yeah, free, streamed online. But yeah, what that is when Kubernetes launched in 1.0, it only supported Docker. And so we had something built into Kubernetes, the kubelet, called Docker shim. And that was basically how the kubelet, the agent that runs on each Kubernetes node, talks to Docker, the container runtime, to run and manage different containers that are being run through Kubernetes. And about, I think, about a year later, we had more container runtimes that we wanted to add to Kubernetes. So an early example of that was Rocket coming out of CoreOS. And initially, we built Rocket into the kubelet as well. But we pretty quickly realized that there wasn't a standardized interface between the kubelet and the runtime. And so we were having to do a lot of one-off things to support different features of Docker and Rocket. And so from that, we built the container runtime interface, which manages, it's basically a well-defined API between the kubelet and the container runtime. And suddenly you have a lot more flexibility in which runtime you're using. We can standardize a lot more features across those. And it also becomes much easier to develop new node features in Kubernetes, because as long as you're using this interface, you don't have to worry about supporting that feature in each different runtime.
Okay, and the containerd runtime is basically just a part of the Docker, all Docker runtime. Because with Docker, you can do things like building an image or running. I don't know, like building an image or I don't have any other examples now, but pulling the image and things like that. And for example, the part of building, you probably don't need it on a Kubernetes cluster, right? So basically what we are doing with Kubernetes is using just a small part of the Docker code, basically, the Docker application.
Yeah, so Docker separated out containerd as that runtime piece that you were talking about. And there's a lot of cool value add that Docker adds on top of containerd. And so they kind of separated out that core component that things like Kubernetes needs from all the more advanced features that you can do with the Docker runtime. And containerd actually supports that container runtime interface I was talking about natively. So you can take that underlying container runtime from Docker and use that directly with the kubelet.
So basically you're saying that you can still run Docker container, well, not Docker, you can run containers that were built with Docker, but you can run them only with containerd. You don't need to have Docker installed on the machines, right?
Yeah, definitely.
And with containerd is only for Docker containers, or can you run Rocket, for example, or containerd? Or in that case, you need another container runtime?
So there's an open standard called OCI, Open Containers Initiative, I think it stands for. And
or interface?
I'm not sure. And so there's an OCI image spec, which actually developed out of from the Docker image spec. So they sort of took that, how Docker builds containers, and said, let's standardize this. And that's the OCI image spec, which now Docker, if you build an image with Docker, you're actually building an OCI image. And Rocket, which it might be defunct now, but it was also building OCI containers, and I think basically that's the industry standard now. So everything that's building container images, you're building these OCI container images.
And how do you debug a problem with a node that doesn't have Docker installed, but is running a container? How can is that a good thing to debug an issue on the node, or you should just destroy the node and create a new one and you don't care? What are the best practices?
So there's absolutely still a need to debug running containers. If we always just said, it's not working, let's restart it, then we would never fix the bugs. There's a few different ways of doing that. If you're running through Kubernetes, there's a new feature that I'm really excited about called debug images, or ephemeral containers. And what this does is, before, if you had to say, you had to exec into a running container if you wanted to debug it through Kubernetes. So you would use like kubectl exec to run a process within the container. But what happens if some tool that you need to use isn't available in that container? To take an extreme example, if you're trying to build a minimalist container image, which has a lot of advantages, you might leave out the shell and all the tools that you use with a command shell. But now if you need to debug it, you don't have any of the tools that you need. You can't even run a command. Right. So what debug images or ephemeral containers lets you do is add a container to a running pod, and you can run any image that you want with all the debug tools that you have and connect to an existing container. So share a process namespace. You can even mount that container's file system into your debug container, and then exec into your debug container and access the running container that way.
Okay, so basically you're saying that we are injecting a container into the pod that we want to debug, and that pod for that container doesn't have anything. Let's say it's a scratch image with a binary running. So do you think that the debug container should mount the files from the other container into this one, but you are not going to be able to see the process running, right? Because they are not different containers.
Yeah, so they can share process namespaces.
Okay.
So you can not just process namespaces, you can control in the ephemeral container which namespaces you want to connect to and share. Okay. So even if your pod, there's actually a configuration on the pod which lets all the containers within the pod share a process namespace. But even if they're not sharing a process namespace, you can still connect that ephemeral container to the target container's process namespace.
Cool. And this is just Docker image. Well, let's say a container image that runs into a pod, and you don't need anything extra, right? You just run a kubectl command to inject that container, and that's it.
Yep, kubectl debug, and then the name of the container that you're targeting.
So it's already integrated to the kubectl command. You don't need to run a command to inject the container. You just run kubectl debug, and that's it.
Yep.
Cool. I didn't know that. 2 things I learned today. Nice.
I think that feature went to beta in 1.23, if I remember correctly.
That's why. Okay, so it's pretty new. Cool.
Yeah. Maybe 1.22.
Okay, that's fine. Awesome. So you've been working with Google, you said like 10 years or something, right? And obviously you are used to see a corporation running kubectl Kubernetes cluster, but probably, I don't know if you have experiences like working on a startup, maybe not recently, but I guess it's really different, right? Because it's not the same thing to run, I don't know how many, obviously you cannot say, but there are 1,000 probably or more clusters in Google, and it's not the same as managing 1 or 2. What are the differences on security-wise that we should take thinking about the corporation or thinking about something smaller? Are the same things that we should be caring about, or there are some things that are different?
Yeah, so the big advantage that a startup has is they're doing what's called, or they're doing greenfield development. To use less jargon, it just means they're building from scratch. Versus a large enterprise company that's been around for a long time often has a lot of legacy applications that they're bringing along. And so if you're starting from scratch, you can start with a lot of those best practices. But even better than that, you can actually start at a higher level of abstraction. What I would recommend there is not to actually build directly on Kubernetes, but look at a framework or a platform that sits even above Kubernetes. I'm personally really excited about Knative and all the work that's coming out of that project. And if you're running your containers through Knative and developing in that framework instead, a lot of those best practices are already done for you. And so you
Can
don't
you
need to
explain a
worry.
little bit about Knative, what it is? Because
Yeah,
probably
sure.
I don't know, so I want to know.
If you're running a container in Kubernetes, normally you build your container image. You have to um, figure out how to deploy it to the
Yeah,
cluster, specify the deployment. If you're integrating with a service mesh, you need to configure the service mesh. You need to configure your network policy. Make sure you're loading whatever other dependencies are on that container. You need to configure your logging and
yep,
your monitoring and all this yourself. Um, Knative abstracts a lot of that away. And so you say, here's my container. Let me run it. It has a declarative way of specifying what dependencies it has, and is generally just like a higher level abstraction.
got it.
It
Cool.
even has things like there's Knative support for functions. So if
Mm.
you're familiar with something like AWS Lambda,
Yep.
there's something like that in Knative. But the advantage of building on Knative is it's an open source tool and it runs
Mm.
on top of Kubernetes. So maybe you start developing with functions in Knative, and then you realize at some point that you need something more powerful, or you need to use a third party application that can't just run as a function.
Mm-hmm.
Because Knative is running on Kubernetes, you can take that other application and run it alongside your Knative code on that same Kubernetes cluster. And because it's an open source standard, you can easily move it between
Yep.
cloud providers. You can run it on prem or wherever else you need to do it.
Awesome. Yeah, that sounds really interesting. I will definitely take a look. So, just to starting to go to the end of this conversation, um, it's really hard for developers to know everything, right? I mean, they need to learn about their languages, the good practices, and now we are trying to teach them Kubernetes and teach them these good practices. No, don't use root containers, whatever. What is the best way, or what are the, I don't know, links or books, or what do you think a developer should be learning and how to follow those practices? Do you think that they should be experts on that?
Um, yeah, so it really depends on what your goals are.
Mm.
Um, and so if you're running, uh, if you're working on, say, for a small startup where you're following a DevOps, um, uh, you're
Workflow.
in a DevOps role,
Yeah.
and I often hear from people who have worked at startups that everyone's doing everything.
Yeah.
Right? You need to be an expert in all the different parts of the stack. There, it's going to be a lot more important to learn all those different best practices, versus if you're in a more kind of a specialized role where maybe you have a security team
Mm.
that is writing policies. For instance, maybe they're authoring open policy agent
Yep.
policies that run on the cluster that limit what you are able to do. Now you don't necessarily need to learn, oh, it's important that I set this flag and whatnot, because that other team has already done all that for you. Um, so it's really going to depend a lot on what your goals are and what kind of role you're in. Fortunately, there's a huge amount of resources
Yep.
available. I don't have specific recommendations for specific resources, but the way I like to learn is usually to start with a tutorial
Okay.
that gets me kind of operational towards my goal.
Uh-huh.
I don't actually learn that much from a lot of tutorials. It just helps me to get that to that hello world kind of point.
Right. Right.
And then I go back and I look at each step of the tutorial and see, like, what is this actually doing? What happens if I change it? How can I do it
Okay.
differently? And then I also like to bring in those best practices and pull up like the CIS benchmarks guide, for instance, and say, how can I follow the same tutorial but apply all these best practices along the way?
Awesome. Yeah, that's a good idea. Basically, just running a dummy application and then try to make it as secure as possible, following following those practices. All right. Finally, what do you think? is the future of Kubernetes? I'm sure that people are asking this all the time, but people think, or well, not think, but they say, okay, Kubernetes is just something that is happening right now, but in the future it's going to be another thing. Or are people saying, no, we're going to use Kubernetes 50 years from now? What do you think? Is that what is the future of containers, Kubernetes, and lambdas or functions?
Mhm.
What do you think?
So one of the kind of the big thing that Kubernetes has been focused on for the last couple of years now and still is focusing on is extensibility. So we already talked about the container runtime interface.
Yeah.
There's lots of different places throughout Kubernetes that there's similar interfaces being designed. I think I mentioned the container storage interface is another one. The community is in the process of extracting all the cloud provider code out of the API server so that can be run separately. And so they're really turning Kubernetes into this very extensible platform. And I think that work is going to continue. And we're going to continue to make Kubernetes more and more flexible and extensible. And a lot of the cool future developments that we'll see, I think, is going to be coming out of those extensions. So not necessarily a new feature in Kubernetes, but a new feature in an extension or a new thing that's built on top of it. I mentioned Knative earlier as another example of where we can build higher level abstractions.
Got it.
So
And below Knative, maybe in the future you will run Kubernetes or another OpenShift, whatever. And as long as you are a community that try to standardize those things, you can. It doesn't matter if it is Kubernetes or not below, right?
yeah, I think another example is if we look at Linux running the kernel. That's a pretty low level component, and we don't. A lot of the more exciting developments are not happening in the Linux kernel, but on all these platforms and frameworks and everything that we're running on top of Linux. And so I think that we'll see Kubernetes kind of develop into a similar role for distributed applications, where it's just this lower level component. And yeah, you have some cool features coming in like eBPF and new features coming into Kubernetes. But a lot of the things that's really advancing the industry is going to be at a higher level.
Cool. Okay. I think that's it for me. I don't have any more questions. Thank you very much for being here, Tim. You helped a lot, making me understand things that I didn't know. And now I have to go and check my clusters and check that documentation that we're going to put on the description to make sure that we are not insecure or breaking anything.
Yeah, thanks so much for having me. It's been a pleasure.
Okay. Thank you very much. Bye bye.
Take care.
Bueno, la verdad que excelente la charla con Tim. Tim. Mira cómo te tiro la pronunciación. Impresionante. Muy buena la charla con Tim, donde hablamos de algo muy interesante que yo no tenía en cuenta, que se llama las debug images. Qué loco, yo venía usando básicamente un contenedor o un hack ahí que se llama kubectl SSH que corre un contenedor en el host, pero con esta cosa que ya viene integrada en kubectl puedes debuguear una imagen que está corriendo. Mirá qué loco, la verdad no lo conocía para nada, así que no puedo esperar para probarlo junto con Knative y esas configuraciones del driver de CSI. Voy a poner todo eso en la descripción para que le hagan clics y lean un poco, porque de nuevo, acá estamos todos para aprender y es excelente tener una persona de ese calibre en nuestro canal. Así que bueno, eso fue todo por hoy, espero que hayas aprendido algo nuevo. Suscríbete para más videos, dale me gusta si te gustó. Dale no me gusta si tus métodos de seguridad en tu clúster de Kubernetes consisten en entrenar un gallo, una cabra, una llama y un hipopótamo, que se pongan uno en cada parte, en el scheduler, en el API controller, el control plane, como daemons, todos esos animales están ahí mirando. Y cuando vos escuches que el gallo hace kikiriki a la mañana, pensás que te están hackeando. Entonces vas corriendo a la computadora, te fijas y no, era el gallo del vecino de enfrente que te despertó porque estaba amaneciendo.